Alright, so we are done the quiz. You should have done homework check number 4. Ms. Hammond, if you could pass out review 6 if you haven't already. I'm going to remind them of a few things. Tonight's homework is review number 6. You have a quiz on Tuesday. It'll be a free response quiz. And on Friday of next week, you should have already completed the 2012 multiple choice test. You need 2 lunches to do so. If you don't do this in your own time, then I will force you to stay 2 days next week. So those of you that already did a part, your tests are still in the same location. Go back and finish up day 2. And then if you did not start it yet and you want to start today, the tests are over by the bins. Take a test and a Scantron, but when you are done, please leave both in the classroom. Alright, we're going to do review 6 notes at this time, so get your packets out or your foldable out and we'll go through implicit differentiation. So, see? Sorry guys. So, implicit differentiation is used when your equation is written implicitly. What that means is your variables are combined and not solved for by a term. So here your x's and y's are combined together, and if I asked you to find dy dx, you would have to use implicit differentiation. For this guy, if I asked you to find dx dt, you would need implicit because of the fact that the variable is t that you're doing with respect to. And then this last one would be implicit because of the fact that this is now a function. In a sense, we could just call that b. And so each of these would be examples. Another example that might be a little bit odd is if I gave you a function, say y is equal to 3x squared plus 2. Looks like it's not implicit unless I tell you to find dx or dy, doesn't matter, dt or d theta, because now all the variables are not with respect to the variable at the bottom of the differential. So we're actually going to do the purple problems. Ms. Hammond, I'm going to just present each of the problems and then give them some time to work through the problem, and you can press pause during those times. Alright, let me get this thing out of the way. Alright, so hopefully you got through the first example. Here we go. So first thing I want to mention is that if you're doing implicit, look through to see if there's a product of functions. Here, there's actually a product of functions, and I just do this to notate that it's a product and that I don't forget about it. I also make the negative go with the x. It ensures that I won't forget about it. So 4x plus, leave the first term, derivative of the second, plus second term times the derivative of the first. So notice the negative is here and the negative is here. It's because it has been distributed out forcefully because I put the negative with the x. 5y squared would be 10y. Need a differential because we're doing this with respect to x, and the derivative of a constant is 0. So at this point, I'm going to collect all the terms with a dy dx, and I'm actually going to just factor it out too. So just so you see the term, I'm going to factor out the negative x and the 10y. So negative x plus 10y, because they have the dy dx's, and then the terms that don't have a dy dx, this term and this term, I'm going to move to the other side of the equation. So I end up with positive y minus 4x, and therefore my last step would be dy dx is equal to y minus 4x over negative x plus 10y. And just so you understand how these negatives all work, this is one answer. If I multiply the numerator and denominator by -1, I'm not changing the fraction, we're doing a makeover, and I end up with negative y, positive 4x, and I end up with positive x, negative 10y. So both of these would be answers, this purple guy and this red one. If only one or two of your signs are changed, that means you made a mistake somewhere. Yes, the terms can be written differently. So like this one, we can write it as 4x minus y over x minus 10y. And this one, without the multiply, we could write as negative 4x plus y over, leaving the x's together, we could do this, but notice all the signs are still the same. So you want to be careful. If you mess up at the beginning with this term up top, that's how you end up losing your negatives, or maybe just one of the negatives are swapped or flipped. Okay? Second problem. Oh, oopsie, I deleted it. I believe it was x squared plus y squared equals z squared, and I want you to find dx dt. I think it was dx dt. Yep. So press pause if you need a little more time to work on that problem. So here we go, 2x dx dt plus 2y dy dt. They each need a differential because the variable with respect to is t, and none of them are t. So they all have to pick up a differential. And then if I want to solve for dx dt, I'm going to move the other terms to the other side of the equation. So I'm going to leave the positive term in front, and then minus the 2y. And dx dt, before I do that, I'm actually going to I'm going to divide both sides by 2. And so I end up with z dz dt minus y dy dt all over x. And you can leave your answer this way. This is not considered a stacked fraction. You don't try to get a common denominator with differentials, so that we're going to leave together. This is the only time that a stacked fraction would be accepted. And then the third one, this one. So again, press pause if you need some time to get through the problem. So I'm going to find dr dt, which means taking the derivative of this function or relation with respect to t. So this would be dr dt, which is what I want on its own anyway. The issue here is this is a product rule. So leave the first one, derivative of the second, plus second one, derivative of the first. So that product rule is tricky, and then that a lot of times is tricky. People will write 1 and lose the function. This type of problem you'll see show up in a free response question. Seen a few free response questions where they give a function in terms of another function. So just be careful with these. I'm going to give you, I think, 2 multiple choice questions to work on. Ms. Hammond, if you could press pause, I'll do the solution once they had enough time to work through. Alright, so I'm actually going to show 2 methods for this guy. Method 1 will be the way that you're probably used to. You would take the derivative of each term. Notice that there is a product, so I'm going to show the product right there. Leave the first one, derivative of the second, plus leave the second one, derivative of the first, plus 2y dy dx is equal to 0. And then most of you would probably find your dy dx. So I'm going to factor out the terms that have a dy dx. I'm going to move the other terms to the other side of the equation, and then I'll solve for dy dx, which is negative 6x minus 2y all over 2x plus 2y. And I can even simplify this, divide every single term by 2. Problem is, when I try to answer the actual question, all they gave me was the x, so I'm going to have to find the y, and that actually takes a little bit of time. So 3x squared plus 2xy plus y squared equals 2. So I get y squared plus 2y, move this term over, 3 minus 2 is 1, equals 0, and I end up with y plus 1 times y plus 1 equals 0. So there's actually only one y value, negative 1, and then I substitute this in. So I get negative 3, and that should have had an x with it. Get back to my pink. Negative 3 times x minus y all over x plus negative 1, which is the y, and we get undefined. So the answer is E. I'm actually going to redo the exact same question in a different method, so this will be method 2. So method 2 just shows that depending on the question, you may not have to fully solve for dy dx. So method 2, I am going to take the derivative. So I still have the 6x plus, leave the first, derivative of the second. Let's see. plus leave the second derivative of the first, plus 2y dy dx is equal to 0. And the difference is, in this problem, I can actually go straight through and substitute in my x and y right away. The reason I can do that is they're not asking me for the derivative, they're asking me for the derivative at a value. So I only care about the term, the dy dx at a singular point. So I don't ever need the function, or sorry, the derivative simplified out. So y was -1, dy dx equals 0. So what you'll notice is the dy dx's cancel, and I get left with 6 minus 2, which is 4, equals 0, which is not a true statement, which is why it's still undefined. Okay? Second problem. This one, I am going to give a little hint. There is no rule that you know for an x to an x. We have x to a power, and we have constant to an x, which you guys know as a to the x. So we have those two rules, but notice we don't have a rule for x to the x. So you're not allowed to have x to the x. So my hint to you is this can't be a power anymore. There's my hint. Get working in your groups. Hopefully one person at each table remembers what to do. Okay, so at this point, hopefully you figured out that I'm just going to rewrite the function with y instead of x squared, or f of x. So this is actually a pretty lengthy problem. To get a power to not be a power anymore, you would actually have to use an ln of both sides. It's the only way to move the power down. So once I do that, I end up with ln of y is equal to, now because this is the ln of an x to an x, or a base to a exponent, the exponent, sorry, tripping over my words, the exponent can be multiplied in front as a multiple, and then you're just left with this guy. The reason why this problem is a bit of a pain is because when you do that, you end up with a product rule over here. So, because of the product rule, and then also over here, this is now implicit differentiation. I would do the derivative of ln of y is 1 over u times the derivative of u, in this case that would be dy dx, is equal to product rule, leave the first one, derivative of the second, this is a chain rule, so 1 over u times du dx, that's a chain rule, plus leave the second term, times the derivative of the first term, which would be -3. And then this is optional. Just because it's one easy term to move to the other side, I'm going to. So it would be y times, and I'm just going to write this out a little bit neater. So it would be 2 minus 3x times 2x all over x squared plus 1 plus, actually I guess it would be minus 3 ln of x squared plus 1. Alright, and then same reason why we solved for the point before, because it says y here, I'm going to actually need the y value, so f of 1 would be 1 plus 1 to the 2 minus 3. So that would be 2 to the -1 power, which is 1/2. So the y value is 1/2. So we can substitute that in. One half times, so here I'm going to substitute in my x value of 1, so I get -1 times 2 all over 2 minus 3 ln of 2, it looks like. Alright, and then we get 1/2 times -1 minus 3 ln of 2. We end up with, trying to make this match up with something that's up there, a little difficult here. Let's see. 1/2 times negative 1 minus ln of 8. Let's see. Interesting. So, let's see. So this one is going to be nice because I can go over some ln rules with you. Moving back, so just making sure you know how I got from here to here. What I did was I rewrote 3 ln of 2 as ln of 2 to the 3rd power, which is how I got the 8. And then I noticed that my answer has to be one singular term, so I was trying to figure out what I could do to this guy to get one singular term, and I could combine it if this had an ln with it. So what I figured out was the ln of e is 1, so I did 1/2 negative ln of e, which is the same as 1, minus ln of 8. But what I wanted to do was take out the negative. And then I know that if this is a addition, to combine 2 ln's with an addition, I can do a product. 8 times e. And that is letter A. So it took a lot of simplifying to get down to this answer. This is a problem that would definitely take a little bit more time. Alright, and I think that was the last one. Oh no, there was one more. I don't know if you guys have time for one more problem. If you do, great. If not, the video will be online with this problem completed. And I'm going to do the problem now. If there is time, Ms. Hammond, go ahead and press pause and let them work through. So, here we go. This guy is not fun. That is not only a chain rule, but it's also a product rule. So to take the derivative of just that term, I would have secant squared. That's the derivative of the outside. Leave the inside alone. Times the derivative of the inside, which is a product rule. Leave the first term, derivative of the second, plus leave the second term, derivative of the first, equals the derivative of x is just 1. Let's start moving some terms around. So this term I would move to the other side of the equation, and I would get x dy dx is equal to, plus y is equal to 1 over secant squared of xy. But that's the same thing as the cosine squared of xy, so I have a feeling that they're going to want to use that term. Next piece, I would have to move the y over, so x dy dx is equal to cosine squared xy minus y, and then dy dx is equal to cosine squared xy minus y all over x, which is, I believe, e. So just a reminder, homework number 6, if you've missed any of the packets or you feel like you're struggling with any of the packets, I would go back to those, try a few more multiple choice if there were some, because I haven't been assigning all of them. Alright, and I will put on Edmodo which questions to do, because I think this packet had a lot of free response and I don't need you doing all of them.